Hello everyone, and thanks for joining me. In this video we want to talk about a very important example or exercise in which we'll develop a probability mass function for a random variable, and we calculate mean or expected value and variance of a random variable. So let's jump right in. It says the sample space of a random experiment is A, B, C, D, E, F, so 6 outcomes, and each outcome is equally likely. So when we have 6 outcomes and they're equally likely, essentially the probability of each is 1 over 6, right? A random variable is defined as follows. So here we're having the 6 outcomes listed, and random variable x can get value of 0, 1.5, 2, and 3. When outcome A or B occur, the value of random variable is 0. In case of outcome C or D, the value is 1.5. When the outcome is E, the value of random variable is 2. When the outcome is F, the value of random variable is 3. So the problem is asking us to determine the probability mass function, mean and variance of x. So here you're seeing that PMF, mean, and variance are all associated to x, right? Variance, mean, PMF, they're all referring to x. And here I'm emphasizing on this because it's a very common point of mistake that we essentially say that, well, the probability mass function of x is equal to 1 over 6. Because the probability of all these outcomes are the same as 1 over 6, so PMF is equal to 1 over 6. But that's not true. The probability of each outcome is 1 over 6, but x is different. X is defined as a random variable that can get these 4 different values: 0, 1.5, 2, and 3. And we are developing the PMF for the x. So you can think of, so if I want to give you a real life application, let's say that you're throwing a die and there are 6 outcomes when you throw a die, 1, 2, 3, 4, 5, 6. And let's say that x is representing the amount of reward associated with each of those outcomes. If your die lands on 1 or 2, you get 0 points. If the die lands on 3 or 4, you get 1.5 points. When it lands on 5, you get 2 points. When it lands on 6, you get 3 points. So just to give you a perspective of how does this random variable behave. So when we are developing a PMF function, first of all, you essentially need to list the probability of all possible values of x. And all possible values of x is 0. F of x is 0, needs to be calculated. F of x at 1.5, f of x at 2, f of x at 3. And what they mean essentially means the probability of x when it's equal to that value. Now, what is the probability of x when it's equal to 0? Well, we know that 2 outcomes will give us x equals to 0. And those 2 outcomes are A and B, and the probability of them is 1 over 6. So 1 over 6 plus 1 over 6, 1/3. So 1/3 is the probability. Probability of x equals to 1.5 is the same. 1 over 6 plus 1 over 6, so 1/3. And that is because we have 2 1.5s here, and probability of each of these outcomes is 1 over 6. For x equals 2, the probability is 1/6, and here also 1/6, because there's only one outcome associated with those 2 numbers. So that's right there is your PMF. Now, how do we calculate the mean and variance? Well, we know the formula for them. Expected value of x, or mean, is the summation of x f of x. And in this case, it's basically 0 times its probability plus 1.5 times its probability plus these. So it's going to be 0 times 1/3 plus 1.5 times 1/3 plus 2 times 1/6 plus 3 times 1/6. And that is equal to 1.33. That's the expected value or average of this random variable. So back to that example that I gave you, the amount of reward associated with different outcomes of throwing a die. This expected value here essentially telling us on average you're going to receive 1.33 points every time that you're going to roll this die. This value only shows you the central tendency of this random variable. We know that it's not possible that you get 1.33 points. That value is not among the values that x can get, but it shows the central tendency of that random variable. Now, how do we calculate variance of x? Well, we know it's expected value of x squared minus expected value of x squared. So expected value of x squared is summation of x squared times f of x minus 1.33 squared. Well, to get the first part of this, x squared times f of x, all we need to do is just go back to this calculation here and just square the x values. 2 squared, 3 squared, and do the same math. So when you do the math here, you're going to get a value close to 1.15. And that's the variance of this random variable. So to wrap up here, the very important point of this example was that there is a difference between outcomes of a random experiment and the values of any random variable associated with that random experiment. They do not map to each other one-to-one. Here you saw that we have 6 outcomes, but we have 4 different values of x. So this is a very important point when you're developing PMF functions and calculating expected value and variances in future.